At first glance, the C++ standard library accumulate algorithm seems highly situational and only mildly useful at best. However, I think that with a bit of creativity, it can become one of the most powerful algorithms. Later in this video, I'll show you how you can find the longest word in a string or format the license plate using this algorithm. But first, let's look at the basics. The simplest application of the accumulate algorithm is getting the total of a range. We provide the beginning and end and some starting value. It adds all the elements in this range to the starting value and returns the result. It's also possible to provide a custom function for the algorithm to use. Like in this case, we multiply all the numbers together instead of adding them. One important thing to note is that the start value does not have to be of the same type as the elements in the range. For example, floats can be added to a complex number, so we can accumulate a vector of floats using a complex number as a starting value. What exactly a complex number is not important for the purposes of this video. All you need to know is that a complex number plus a floating point number equals another complex number. This concept is what makes the accumulate algorithm so powerful. Writing our own structs or classes in combination with this algorithm can do a whole lot more than you think. Let's start with a very simple example, calculating the average of a given range of float values. We start by defining a class called average_accumulator. This class will be used as a starting value when accumulating a range of floats. We need the amount of elements and the ongoing total, and a simple constructor initializing them both to 0. Next, we'll overload the plus operator. The accumulate algorithm will automatically use this if no custom function is provided. Side note, only overload the plus operator if its purpose is unambiguous. In this case, it's clear what an average accumulator would do, so I've opted to use operator overloading here. This operator simply increments the amount value and adds the next float value to the total. Next up, we simply need a way to get the average. I've opted to return an optional float here because an average of 0 elements cannot be calculated. To calculate the average, we first check if calculating an average is possible and do an early return if it's not. Then we return the correct average value. Now we can use this class by simply providing it as a start value to the accumulate algorithm. The resulting value will contain our correct average. Let's move on to a more interesting example, finding the longest word in a string. For simplicity, we'll define a word as an uninterrupted series of so-called word characters. We'll make a function called isWordCharacter that can help us with this. A word character can be a hyphen, apostrophe, or an alphabetical character. If it is neither, the character is not a word character. This is indeed overly simplistic, but for the purposes of this video, it will do. We'll start by defining a class called longestWordAccumulator. We'll need to know the current index, size and index of the ongoing word, and the size and index of the longest word. We'll also give it a simple constructor and some getters we'll need later. Just as before, we'll overload the plus operator so it can be automatically detected by the accumulate algorithm. In this function, we'll start by detecting if the current character is a word character. If it is, we'll check if there's already an ongoing word by checking the current word size. If this is 0, it means we just detected the new word and we should move the current word index to the current index. After that, we'll increment the size of the current word, and if the character is not a word character, it means that there's no longer an ongoing word. To indicate this, we'll set the current word size to 0. After that, we need to check if the current word is the longest one so far. We check if the current word size is bigger than the longest word size and override the values if it is. And lastly, we increment the current index and return the accumulator. To use the class we just created, we provide it yet again as a starting value to the accumulate algorithm. To now actually get the longest word, we can use a substring method using the start and size provided to us by our accumulator. For our last example, we'll try something more complicated. We'll format a license plate. To do this, we'll need to establish what a correct license plate looks like. A license plate will exist out of segments separated by a hyphen. A segment is at most 3 in size and will contain capital letters or digits, but not both. Let's start by implementing a license plate formatter class. This class needs the result, aka the formatted license plate, and the type of the last valid character. This type can be a digit, letter, or it can be invalid, which it will be at the start. We also need the amount of consecutive characters of the same type. We'll implement a simple constructor in which we reserve a reasonable size for our formatted license plate. Yet again the plus operator and a getter for the result. I'd also like to show that since C++20, the accumulate algorithm will move the ongoing value instead of copying it. This means that our result value won't get copied all the time. To prove this, I deleted the copy operators. Let's implement the plus operator now. We'll start by checking if the current character is valid and return early if it's not. Next, we'll need to know if a character switch has occurred. We do this by comparing the current character type to the previous one. We also need to know if we reached our maximum segment size. To do this, we check if the amount of consecutive characters is greater than or equal to 3. If either of these conditions are satisfied, a new segment should be created. Our first segment at the start of the string should not have a hyphen. To make sure this is the case, we check if the result is empty and add a hyphen if this is not the case. Next up, we need to update the last character type and reset the amount of consecutive characters. Now, all that remains is incrementing the current character count and adding the current character. Then we can return our formatter. And this is the final result. Let's check if it works as intended by writing some unit tests. All looks good. All the code and tests can be found on GitHub via the link in the description. Since this is my very first video, I'd greatly appreciate any feedback in the comments down below. Please subscribe if you want to see more videos like this, and thanks for watching.